Welcome to 65th lecture of Digital Electronics. In this lecture, we will be dealing with first one is 16:1 maths. Second one, realization of 16:1 maths using 8:1 maths. Okay, so these are two topics here, and in the next lecture we will realize this 16:1 maths using this 4:1 maths. Okay, now coming into 16:1 maths. 16:1 maths. So first I am drawing the function table or truth table of 16:1 maths. Function table. So you are having selector switches, output Z. So selectors I am writing it as same A, B, C, D. I am given the name as A, B, C, D. 1, 2, 3, 4, 5, 6, 7, 8. 7 and 8. Yeah. So this 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So here the output is D0. This is D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, and the last one is D15. Okay, so we can write Z as A bar, B bar, C bar, D bar, D naught, or A bar, B bar, C bar, D, D1, or A bar, B bar, C, D bar, D2, C, D bar, D2, or A bar, B bar, A bar, B bar, C, D, D3, or A bar, B, C bar, D bar, D4, or then what is D5? That is A bar, B, C bar, D, D5, or A bar, B, C, D bar, D6, or D7. That is A bar, B, C, D, D7, or A, B bar, C bar, D bar, D8, or D9. That is A, B bar, C bar, D, D9, or A, B bar, C, D bar, D10, or A, B bar, C, D, D11, or A, B, C bar, D bar, D12, or A, B, C bar, D, D13, or A, B, C, D bar, D14, or A, B, C, D, D15. So this is the basic expression of a 16 by 1 math. So here you have, I am not drawing the entire circuit because it is a very big circuit, so I am not drawing the big circuit. So here we are having 16 by 1 maths, and here we are having D0, D1, D2, D3, D4, etc. up to D15. Then selected switches I am having it as A, B, C, and D. These are the selectors. Selectors are here. These are the inputs. Okay. Now output is Z. Okay. So you have the expression for this 16 by 1 maths. Okay. So that is all about this 16 by 1 maths. Next I am going to realize this 16 by 1 maths. Next heading is a realization of by 1 maths using 8 by 1 maths. Now if you are looking back to the function table, I am taking here the first 8 elements. The first 8 elements A is equal to 0, and in the next 8 elements A is equal to 1. So you can consider that as A and A bar, and BCD remains the same. So if you are taking like that, you can draw like this. You can draw an 8 by 1 maths. 8 by 1 maths with inputs as D0, D1, D2, D3, D4, D5, D6, and D7. Means here if you can see, D0 to D7 should be excited when A is equal to 0. That means you should get NOT gate in between. So this is A, and BCD remains the same. So you are having B here, C here, and D. And again if you are having another 8 by 1 maths, and here the output is say Z1. If you are having another 8 by 1 maths, where the input is D8, D9, D10, D11, D12, D13, D14, D15. Then we can connect that direct part here. Okay, right. Okay, that is here we are having A is directly connected here, B, C, and D. That can be directly connected. There we will get Z2. And if you are clubbing, if you are ORing this Z1 and Z2, if you are ORing Z1 and Z2, you will get the entire logic. Okay. So this is how you are realizing a 16 by 1 maths using 8 by 1 maths. That means here when A is equal to 0, or okay, when A is equal to 0, what happens? Here you will get 1. That means 8 by 1 maths number 1 will be triggered, and when A is equal to 1, this 8 by 1 maths number 2 will be triggered. So totally you can have 16 inputs, but that is divided into 2 8 by 1 maths. Okay. So that is how we can realize a 16 by 1 maths using 8 by 1 maths. So that is all for this lecture, and so we have started with a 16 by 1 maths and expression about the 16 by 1 maths, and we can draw the circuit. Okay. So circuit is a very large circuit, that is why I am not drawing that large circuit. So I have made it into a block diagram, and after that I have realized it into a realized 16 by 1 maths using 8 by 1 maths. The only thing is here if you are choosing the selectors, the selectors, that means A is chosen as the selector between two 8x1 matrices. Okay, so with that I am ending with the lecture, and in the next lecture we will try to realize the 16x1 maths using 4x1 maths, and and we will realize the basic one, that is 4x1 maths using 2x1 maths, and after that we will go with some applications of multiplexers and how to implement a given logic function using multiplexer. That is in the coming lectures. So thank you, hoping you to be there for the next lecture also. Thank you.